GUI programming and Matplotlib. So, in machine learning, we use GUI programming in the sense we have a package called Matplotlib. So, we started the GUI programming journey from console. Then we saw that how simple X11 X client programming happens. And then we saw that how there are two entities in any application which write the GUI program. One is event dispatcher, event manager, or if we talk in kind of object oriented like Qt, then it is queue application and queue window or window generation. So window generation and event queue management. So there are two things in an application. And then it grew to heavyweight X server, and X server does everything. So X server is like an operating system, which which hooks to the device driver and receives the hardware events. Then it changes the hardware event, the hardware byte sequence it formats into data structure, and then fills the window ID and then event ID and everything and passes it to the particular X client, and the queue application or the event dispatcher that is managing the event queue, it receives the event or it fetches the event from the X server, and then it passes the event to the window owner, and window owner once is received the event against this what the window it owns, then it executes the event callback function. Now in event callback function, it demands for the kind of rendering request because he wants some changes on the window. It goes back to the X server, and X server honors the rendering request, and it fills the window buffer as per the rendering request. And then to make the full whatever the rendering request it has received from all the X client, it does the window management, and then Linux frame buffer or the screen buffer or desktop the desktop full management, so that it does, and then it does the final overlay on the video buffer that connected to the screen. So that is the story. Now the window management, window bookkeeping from the X server is went to window manager. So in the X server architecture, two guys came up, X server and window manager. But as the software developed, means Linux world came, so many things started coming as their own, means filling the window buffer. For each window there is a buffer in which the graphics data or pixel or images need to be filled. Then OpenGL came, and through DRI, direct rendering interface to the graphics algorithms like EGL or GLES2 and then DRI2, it became possible that to write on the window buffer. So X server that job gone. Then config, then X fonts used to happen. Font config came. High class 2D X rendering, for that Caro came. Event management, memory management. So memory management also came separately, and then the event what is received from the peripherals. So that byte sequence event to the event data structure EVDEV came. Final overlay for that KMS came. Like that, everything came. X server does only it is doing bookkeeping and desktop management. So that anyway it is being done by window manager that is sitting side by the X server. X server removed, not required. So two big processes running, not required, because all the work that is being done, that has been being done is now not required. Everywhere new full-fledged extra either kernel module came as separate, or client can write using the OpenGL, EGL or DRI interface directly to the window buffer. So that story we saw. So X server kicked out, and the window manager that is sitting side by the X server, that became full-fledged guy which would talk to the client, and client are getting called Wayland client, and this window manager is now Wayland compositor. So Wayland compositor has no job. It receives formatted event data structure from EVDev, and then for everything it uses the modules like font config module, Cairo module, or if required Qt module or memory management module. Then it passes the kind of the events to the Wayland clients through Wayland protocol, and Wayland client write on their own window buffer through OpenGL, EGL, GLES2, DRI interfaces, and then so earlier it used to inform X server with rendering request, and X server finally it used to inform the window manager with the damage event. So now now Wayland client just send the damage event to the Wayland compositor, means this much graphics is required, and through the protocol between the Wayland client and Wayland compositor, through the protocol, Wayland compositor now knows that which is the new buffer where it has been written, because there can be back buffer where client writes and passes it to, so it flips. So page flip it does, and then it manages the full data. So final Linux frame buffer or application or the screen buffer it writes, and then it passes to the KMS for the final overlay. So the Wayland compositor, it's not an Excel, it's not a new Excel, it's a kind of arbitrary, means whatever it just manages now. It's become a real manager. All the separate entities have come up full-fledged, OpenGL to KMS to EVDev to Cairo to font config to Qt to high-class memory manager. So many things came, and it is just delegating whatever is coming from one guy to another guy and this and that. So this is Linux. So this is the scenario in the Linux. Now, when so many guys came into the picture, one more guy it is popping up, that is machine learning. So in machine learning, whatever the idea, whatever coming to our heart, the idea, the algorithms, what we want to draw. So if we have 50 features in machine learning and we need to draw 50 features, not possible. So generally we use PCA and we bring it to 2D or 3D. Then we draw the graphics. So Matplotlib. So we'll talk about Matplotlib. So how Matplotlib is getting drawn. So idea to bring Matplotlib into the picture, it is confusing. Means when you see any drawing routines, there are two things. When we come to client or application, two things. One is event queue, the guy who manages the event, because every graphics is event based. Whatever we are doing on the windows, actually we are raising an event, that's it. Event is coming to event queue, and now it is intelligence that how the final code, means event callback would be called for that particular event, and then the rendering would happen in the window, and then finally through the window manager or window compositor or Wayland compositor. Okay, but there is no concept of event queue or windowing, nothing. Only Matplotlib. From Matplotlib, import PY plot, and from PY plot start calling function. Draw, scatter, legend, then get the axis, this gland. Yes, it is. I means no one can understand. Impossible. If you don't understand the design, if you don't understand the step by step, then you cannot walk also. Means if we walk, then there is a procedure in it. Means our children, when it raises up, he is being taught how to walk. Otherwise he would fall. Means walking is that difficult. Then full-fledged 2D drawing and 3D drawing, just with some Matplotlib PY plot function, means where is subplot and where is axis and where is legend, and where is axis kind of granularity, and then what is the scatter, how we draw the line, and then where we draw the rectangle, and which would go there, then how we'll make to do it with 3D, and how would make it transparent, and or alpha, means I don't know, means who has designed the architecture of Matplotlib. Only God can help him, means amazing. Okay, whatsoever. Now, how we can bring the Matplotlib in our pattern, what the pattern we are flowing, the two things constitute an image, one drawing. One is event queue, where event is placed, and event queue dispatcher which dispatches the event to a particular window owner, and window owner finally execute the event callback function. And in the event callback function, actual calls are done for the drawing, and finally it is going back to the event queue for the GUI libraries to finally come up, so to make the actual drawing through event mechanism. Up till here, beyond that, we OpenGL and Compositor and KMS and EVDev and those guys take care for the finally to come up to the screen. But this much, the event queue management and window management in the application or X client or Wayland client. So that concept is required. So in Matplotlib, the two thieves, the two guys, what we have been talking, kind of are figure. One is figure and one is axis. So figure is application, event manager, event dispatcher, and axis is the window. So if I have 4 axes, so I may call subplots. So first, if I have py plot, then I can get the figure out, and I can get the axis out. There is API where I can say figure or get figure. I can take out the event manager, and then I can say get the axis. So then default window, so figure is application, and the default window that is covering the main application. So that is the single axis that will come out. Now axis means window. So now if we have a figure, that is the event manager, and axis is the window, that is the queue window, or figure is the queue application. Now we can write code. So all the drawing, line drawing, this drawing, that drawing, would go to axis. And all the kind of, they call it artistic, means ready-made drawings like rectangle, ellipse, or star, point, these kind of drawing, they call it artistic. So all the artistic, so they will also go in the axis. You can take out x-axis, y-axis, and then you can set the resolution that will also go to the x-axis. You can place legend that will also go to axis. You want to draw a line, you want to scatter something, that will also go to axis. So axis is window. So in the window, whatever we want to do. So window generally does two things. So how kind of how the fixed drawing would have, like background color and background image and those kind of things, and then it kind of enjoys the drawing. Third thing that Qt does is, in Qt program or any programming, window does layout. Layouting in the sense that a window has sub windows. So if I need 4 windows, we have a root window. Inside that 4 windows would come, and that we can do layouting. So layouting, they have shifted to figure. So figure being a event manager, it does the layouting in the sense that it contains window. It is managing the anyway window we are registering with the figure, means axis we are registering. So we can say add axis in the figure. So we will add axis. So figure knows all the axes, all the windows. It does layouting. So that is the one thing. Otherwise, it has a function called show. Show at the end we call show. If we call show, then show would start kind of executing events one by one from the event queue. So figure is the event manager queue application in the QV, and axis is the window. Now we know this concept, then we know that which function would belong where. And once we know that, like all the event related anyway it will come. So now we'll come to kind of final design of the Matplotlib, whatever they are showing. So Matplotlib comes into 3 layers. The first layer they call it scripting layer, then artistic layer, and then backend layer. In the backend layer, we have figure function, class and access class, 2 backbones that are separate and they does work separately. Above that there is artistic layer and then scripting. Scripting layer is a meshy layer. The scripting layer, we have all the functions that can be called through the most upper layer like py plot, or if I get subplot, then through that we can call figure functions, we can call axis. We don't know where it is going. We just keep calling. So once we keep calling all the scripting function, top layer function, then in between artistic layer comes in, and then it decides which function belongs to which backend class. So if there is I say one rectangle you place here, then you know rectangle is artistic class, artistic is a separate class. It will come down and then it will instantiate artistic class, axis class and figure class, so many classes, whatever is there, and then it will get it interoperated. So 3 layers in the Matplotlib. One is scripting that someone need to call from the top layer blindly without understanding anything, mug up, remember, write on a paper and keep referring to it. Means without any architecture. Real architecture comes into the second layer, that is artistic layer. It understands the architecture and whatever has been done at the top layer, it dissociates into axis classes and figure classes. And then it calls if it is a really artistic function like rectangle or circle or ellipse or cuboid or whatever need to be drawn, or 3D or 2D. Those classes it calls against axis and figure. Those are the backend classes. So this is the architecture of Matplotlib. Enjoying? So we have come to same under the tree that we have an application and we have a windowing system. One receives the event, process the event, windowing system receives the event that belongs to it, and then it calls the event callback, belongs to the event queue, there drawing happens, and then drawings are finally generated in the kind of events that is again getting processed in the event queue through GUI API, and GUI API nowadays in Wayland compositor architecture, those are OpenGL, EGL, GL, ES2, and through DRI2 it goes to the window buffer directly and then communicated to the Wayland compositor through Wayland protocol, and Wayland compositor does the final that communication. It calls also as a damage event, and damage event is respected in the sense that all damage events are received from the X client. And final, the desktop is drawn with all the windows, and then the screen buffer finally goes to the KMS. So EV dev to compositor, Wayland client, and then from Wayland client it comes to figure, and from figure it goes to axis, and axis does the work and come back to figure, then it goes to the actual rendering through the OpenGL. Then through damage event it goes to the compositor, and then it goes to the KMS. So this is the kind of full Bible and full architecture someone can understand, and this is how it is crucial in the sense because Matplotlib is not simple thing, because in OpenGL, in machine learning, diagrams are very important. Through PCA we can reduce the dimensionality, means number of features, and diagrams are highly helpful. So if we don't understand the architecture in the diagram, then we can proceed to some level, beyond that we cannot do. So this is how the story is, and we can enjoy 3D graphics also. We can enjoy animations also. So in machine learning, new class of things are coming, like NumPy array. So that is a modified array. Then we have, anyway, we have world class scalar. Now we have Matplotlib, we have SCIPY, then we have a data frame, we have Panda, and then we have very important, that is SK image. So these are the coming in machine learning packages, and they are ruling. So probably we will discuss other architectures in other libraries like NumPy or wherever we find hindrance, showstopper, and people should know. So let us start using Matplotlib.